Now, we looked a little bit in the laboratory about the redshift of stars, and we're also going to see that the redshift applies to galaxies. Now, what we have found is this, that most galaxies, well, actually all galaxies, are moving away from us. And that when they move away, okay, the farther they are away from us, the faster they're moving away from us. And so if we see the approximate distance away from us, this is 78 million light years away from us. It's moving about 1,200 kilometers per second away from us. But if you go to 2.3 billion light years away from us, that's moving at 39,000 kilometers away. And if you go to 3.6 billion away, that's 61.2. Okay? As we go farther, they're moving faster away from us. That was kind of a spectacular look. The person who developed this relationship was Hubble. Okay? I'm going to introduce Hubble and what his experiments were. Hubble was an astronomer, and what he was looking at in the night sky when he started his work were what he thought were nebulas. Okay? The definition of a nebula is a collection of gas. Okay? When you look in the telescope, what it does, it looks kind of fuzzy. It's kind of star-like, but it's just fuzzy. It's not sharp. And so he thought he was looking at gas clouds. After a lot of looking, he realized he wasn't looking at clouds of gas, but what he was seeing was, amongst all of those pinpoints of lights that are actual stars, he was beginning to identify different galaxies that were out there. Those galaxies were just as big as us, they had just as many stars as us, but they were very far apart from us. And there was really not much between us and those galaxies, almost entirely empty space. And so his discoveries for the recession, or them flowing away from us very fast, was very important. And so, remember, when we looked at all of this, we saw that all stars, when we looked at this, we saw that all stars, and now all galaxies that we see, are shifted to the red. Now, as he started to collect this data, he found a linear relationship. The farther it is away, the faster it goes, and it goes in an absolute straight line. And that proportionality is now called Hubble's law, and it was a big deal in terms of thinking about the organization of our entire universe. It also allows us to reverse time. If we know that they are receding away, if we reverse the time factor, we can calculate, well, if they're all expanding away from each other, reverse it, they should all come together and come to an approximate time where the universe actually began. Is a really strange thing called a quasar. Okay? A quasar is very far away from us, and it's got two distinct properties. Okay? This is what quasars do. They are very high sources of radio waves. Okay? We said that stars can put off radio waves, but usually they don't put out a lot. This thing puts out a huge amount of radio waves. Secondly, in the night sky, when we look at a quasar, it is bright. Okay? Usually bright stars are very close to us. And so when they looked at a quasar initially, they thought it was pretty close. But the combination of how bright it is and then determining where it is it is really, really far away, okay, meant that, remember the flashlight? If it's real close in your face, it looks bright. But if it goes really, really far away, it looks dim. Well, it's really, really far away, and it looks like it's as bright as it is in your face. That meant its inherent brightness, how bright it really is, must be overwhelmingly powerful. Okay? It couldn't be one star. What we're going to find is that it's a really strange thing. And so a quasar, there's a possibility that all galaxies at some point in their development could have been the... Okay, yeah. If they don't believe in a creator, how did the universe start? Okay, it's kind of like, really, it's a faith statement. And so here's what happens. Everything that is in the galaxy and the universe today was compressed into something they don't know what it is. Okay, they can't describe what that is. But that includes all mass, all energy, time, everything was in one single point. And then they start describing what happens when it explodes. Now, what they don't ever talk about is, well, where did that come from? That's not part of the discussion. They start talking about, okay, and then the Big Bang happens, and then they start their discussion about how things can happen. But there is no consensus, and almost to the point of even denying that there could be anything before that, or where did that come from, or from what that came from. There's no good argument about why. Is there anybody significantly looking into that? Most cosmologists, and these are the scientists that look at this, are really trying to understand, and they spend their time trying to explain what they see after the Big Bang happens. And what happens for them is this. Every mathematical model they make, because this is the only way we study it, we can't observe it, so they try to model it, and that's the science. Everything breaks down when you get to within fractions of a second to the Big Bang. And since they have no mathematical way to model it, it gets into more philosophical for them. Really, you may not call it philosophical. You get into, they won't admit this, a religious, it was always there. Essentially, everything existed for all time, just in a different form. And now we see this form. And because there's no way to, a lot of this is and a lot of people that talk about this, they are mathematics based. When the equations break down, it's out of their realm. And they don't tend to even go that way and go into that area. All right. And so if you look at standardized tests, most likely the answers will be in the 14 billion year range for what is accepted, even though these new papers about a little bit less in the 13 billion range are starting to come out. They haven't been truly accepted by everyone. Now, we've alluded to this. If everything is expanding, everything going away from each other, reverse it, it should all go back to one place. And this is one of the supports for the idea of the Big Bang. So the discovery that space is actually expanding was kind of a really kind of surprising outlook. And then you've got to think about, and they've never answered this question. Okay, if the physical space of the universe is expanding, what is it expanding in? Okay, where is the edge of the universe? These are questions that haven't been answered well or even attempted to be answered well, but they go back to, okay, I see what's the stuff I can see, it's expanding, so it must have been at one point, it must have exploded. And so we as scientists tend to focus on what we can actually see, measure, and explain mathematically. And so we keep, the scientific community keeps their focus kind of very narrow in only things that they can explain. If it's outside that realm, then it's philosophy or religion, and they don't believe in that. Now, the idea of the Big Bang itself, well, that can produce the expansion that we see. Also, mathematically, when they calculate what is out there, what is determined is that there should be 3 times as much hydrogen as there is helium if the Big Bang happened in the way we understood. Additionally, we should have some cosmic background radiation or energies that are still there from the explosion. Now, here's something. When we look in the night sky, we do see a ratio of 3 to 1. Okay, you could argue this. Did we do our mathematics and say there's 3 to 1 and then look and saw 3 to 1? Or did we see 3 to 1 and we did all of our mathematics to match that? That could be a valid argument about, okay, so you're just matching your analysis to match what we see. So you can prove, it could be a circular argument, all right? There are some things, though, that have been discovered independently, searching for totally different other things that actually confirm themselves. And when that happens, when 2 groups of people are looking at totally different things, end up realizing they were really working on the same thing, and it comes together, that kind of puts aside a little bit of question about, are they trying to make it look right? Are they trying to just satisfy their own beliefs by making their experimental data look like that? Here's an example of where different researchers take different set lines of information, different experiments, and they collided to justify themselves and this idea of how the Big Bang might have worked. So, 2 people working on it. One person thought it was a mistake. The data that they were seeing, they assumed it should be 0, not 3 degrees. And so they were trying to find out what in the world was going on with their equipment and trying to correct for it. They thought it was an error, when in actuality it fit the models that were developed around the Big Bang and what it should be to produce what we see today. The universe was made. I like this one. God went, and there it was, right? In actuality, that's a very simple, kind of cartoonish way that, they never talk about where it comes from. But if God said, which is what we believe, and the universe began, whatever mechanism he used, it was miraculous. And so, we are just trying to see what God did. And there's lots of ways, again, to interpret what is seen. Now, going back to the idea or the question about where did it come from? There were, this debate has been closed now, but there were 2 ideas about the universe itself, because we know things are expanding. There are 2 things that could happen. 1, the universe can expand and continue to expand and continue to expand because of that explosion and never stop. That's called an open universe. Or by chance, you do have that expansion, but we also have gravity working in the universe. And so there was an idea that the gravity might start to slow things down, stop them, and reverse them. And over a long period of time, all of it will come back, and they called that a big crunch, which then might start another Big Bang. And then who knows which Big Bang we are part of. But then again, if you think about it, then that assumes everything has existed for all time. Where was the initial? Even if it went Big Bang, Bang, Crunch, Big Bang, Big Crunch. All right, so these were the two ideas, a closed universe or an open universe. And so what do scientists do? We take lots of measurements. And now we have data that supports one of these two. And the one that it supports is the open universe. Dark energy and dark matter. This is what you're going to find the further you study in school. There is a saying, the more you know, the more you don't know. Okay? You start learning that you don't know as much as you thought you did. And so, when scientists are looking at the universe, things are happening in ways that they don't understand. Things that the math that they have, the ideas of how gravity works, the ideas about how things move around, they just don't work out mathematically. There has to be something somewhere in the universe that's changing things. And so that means we don't know about over 70% of the energy that exists in the universe, something we can't detect. We don't know what it looks like. We don't know what it is. We can't measure it, but we see its effects on the things we can see. And then on top of that, we see lots of stuff in the universe, lots of matter that makes up like the planets in the solar system, rocks and stars. We see a lot of mass, but when we do the calculations, we only see 10% of the mass that is part of the universe. 90% of the mass out there, we can't detect it, see it, measure it, or do anything to it. The more we've studied, the less we know about the universe itself. What are they? We don't know. Are they fundamental new particles that have yet to be classified? We don't know what they are. And so we just know there has to be something out there that is pushing and pulling and changing how the universe behaves, and they have to be a lot of stuff out there to affect the kinds of changes that we are seeing. And so the more we look, the stranger it is, the farther we go out. The next topic that we're going to look at, though, is other things that we find very far away from our solar system. And one of the things that we are really interested in is, well, we see other stars out there. We know that our star has planets. Are there other planets out there?